So, hello everyone, my name is Michał. I come from a Polish company called GrapeUp, where we specialize in AI and cloud native technologies. And today we're going to talk about the AWS infrastructure. Oops, I have a Slack open. Okay. So the goal is to create a real-life enterprise-level AWS infrastructure that will be able to host a user management application comprising of React.js web application, the one for which we can see the screen right now, the Spring Boot backend server, and a relational database. And along the way, I'll try to explain some basic components of Amazon Web Services. So the infrastructure which we'll build throughout this presentation will comprise of a single VPC with 4 subnets in 2 different availability zones. We'll have 2 public and 2 private subnets. In public subnets, we'll host our client application and a network address translation gateway, while in our private subnets, we'll have our backend server and our relational database. Our infrastructure will also contain internet gateway in order to provide access to the internet from our VPC, application load balancer for high availability, and we'll use AWS System Manager to access our instances. So I divided the process of infrastructure creation into 3 stages. First, we're focused on the architecture scaffolding. So we'll create the VPC, subnets, we'll configure NAT gateway and route tables. Then we'll start working on VM and database setup. So we create our EC2 instances, MMIs and RDS. And then we'll move to load balancing, and we're going to deploy our applications. So let's move to the fun stuff. So this is the AWS Management Console. And as a first thing, we should always know the AWS region in which we're operating. That's in the top right corner. So AWS region is the geographical area in which AWS hosts their data centers. And each region is divided into availability zones for data redundancy. And right now I'm operating in EU West 1. It doesn't matter for this presentation, but it might matter for your organization. So let's move to VPC service dashboard. So VPC is basically a virtual network, which is a part of AWS network. When you launch VPC, this is an isolated network area in which you can launch your resources, and you can configure routing policies and so on, however you want. So as a first step, we're going to allocate an elastic IP address, which we'll use later on for creation of our NAT gateway. Elastic IP address is basically a static IP address, which is owned by AWS. And the elasticity basically means that we can easily attach and disattach the address from our resources. So it's not strongly associated with any of our resources. So now let's move to the VPC dashboard, and let's launch our VPC. So as I said before, our infrastructure is going to consist of 2 public and 2 private subnets. So we're gonna choose a setup which resembles that the most. So we're gonna go with VPC with public and private subnet. And here we can specify some configurations for our VPC, such as cider block, for instance. So I'm gonna decrease the IP address space a bit.
Michał?
Yeah.
Just a quick second. I've got a question or a mentioning in the chat. The font is quite small, so the people have troubles to read. Actually, could you make it a little bit bigger?
How about now?
Yeah, it should be.
Is it better, or should I increase even more?
It should be. When I still get remarks, maybe you can just deactivate your camera. Then it's even a bit bigger. Yeah, but let's see. It should work. I can read it.
Okay. So we can specify your details such as cider block or, for instance, VPC name. So we're going to name our VPC user manager VPC. And then we need subnets. So subnets are additional isolated areas, isolated networks inside our VPC. And we need them because we can't launch instances directly into VPC. We can only nudge them into subnets. And subnets allow us to configure different behaviors inside of our VPC. So, for instance, have a public subnet, which has direct access to the internet, and have a private subnet, which doesn't and needs network address translation gateway in order to reach the outside world. So we're going to name our public subnet A. For now, we're just working on the availability zone A. Well, later on, we'll work on the high availability. And our private subnet A. And here, so network address translation, NAT gateway, is used to allow our instances, the private subnets, have access to the internet while still blocking the access from the internet to our instances. And AWS provides a managed service, so they basically do everything for us behind the scene. We just need to provide the elastic IP address, which we allocated at the beginning. Here we can just specify some service endpoints, or for instance, if we need dedicated hardware, but we don't right now, so let's just click create VPC. And that's going to take a while. So in the meantime, we can move back to the presentation. So throughout this presentation, I'm using AWS free tier. So when we create our account, AWS provides us with a 12-month free tier period where we can use some of the resources for free, such as 750 hours of T2 microsize EC2, some S3 storage. S3 is AWS file services service, some relation database hours, and so on. So this is basically what I was talking about. So VPC is the isolated area inside AWS Web Service Network, and we need to have subnets inside our VPC, private and public. And for private subnet, we need network address translation gateways in order to reach the outside world. So when it comes to the security in VPCs, there are three key structures. There are security groups, route tables, and network address access control lists, NACLs. And security groups act basically like mini firewalls. They define allowed incoming and outgoing traffic. And what is important, they work on the instance level. So we attach them to EC2 instances. Then we have route tables, which determine where the traffic from the subnet or gateway should be directed. And every VPC has its main route table, and then we can have custom route tables for our gateways and subnets. And then we have network address access control lists, which are additional security layer on top of the security groups. And their work on the VPC or subnet level. And what is innovated about them is the fact that they support deny rules. So for instance, we can use them to blacklist specific IPs, which we can't with the security groups. Now let's go back to the AWS Management Console. Okay, it's still, okay, now it's, so our VPC was created. We can see it here. If we scroll a bit, we can go to NAT gateways. And here we can see the NAT gateway, which AWS created for us. I'm going to name it NAT A, just to distinguish it from the second NAT gateway, which we'll create in a moment. And now we're moved to subnets, and we'll create subnets for the second availability zone. Now we need to do it manually, but it's pretty simple. So we just click create subnet. We name our, so public subnet B. We place it in the user manager VPC. We choose availability zone B, and we specify the cider block. So we click create, and now we'll do exactly the same for the private subnets in the availability zone B. Okay, so now we have all 4 subnets. So what we can do now is create the NAT gateway in the second availability zone, and now again we need to do it manually. So I'm going to click create NAT gateway, name it NAT B. Just specify the subnet. So the first one was placed in the public subnet A. Now we're going to go for public subnet B. And we're going to allocate another elastic IP address for this NAT gateway. Great. So the last step in the infrastructure scaffolding is the configuration of our route tables. So route tables are responsible for where the traffic will be redirected, outgoing traffic. And we can see that we have here main route table and some additional route table, which is associated with one of the subnets. So first, we're going to focus on the main route table. I'm going to name it main RT. And we're going to associate our main route table with our public subnets. Both of them will have the same routing rules. So we're going to associate it with public subnet B and public subnet A. And now we're going to go to routes and edit the routes. So the first entry basically says that every IP from inside the VPC cider blocks should resolve locally, and that's fine for us. And the second one says that the outgoing traffic should go through the NAT gateway. And we don't want that for the public subnets. All the outgoing traffic in the public subnet should go directly to the internet gateway. So that's what we're going to change. We're going to use the second route table. We're going to name it private A RT and associate it with our private A subnet. And edit its routing policies. So this time we want outgoing traffic to go through the NAT gateway and specifically through the NAT A gateway. And now we need to create a new route table for private subnet B. So it's going to be private B RT, also inside our user manager VPC. We need to associate it with our private subnet B. And edit its routing policies to route outgoing traffic to NAT gateway this time. 0.0, yeah. Great. So that's it. We're done with the first part of the infrastructure. So we created the VPC with 4 subnets into different availability zones, and we created NAT gateways in both of them. So what's next? And now we're going to focus on virtual machine and database setup. So we're going to create EC2 instances, MMI images, and configure our database. So let's go back to AWS Management Console. And this time, let's go to EC2 dashboard. So EC2 are basically virtual machines provisioned with some memory, storage, network capacities, which are managed by AWS and are launched in one of the AWS regions and availability zones. And the elasticity means that we can scale them up and down easily depending on our requirements. So let's start with creation of our first instance. We're going to start with the instance for backend server in availability zone A. So we just click launch instance. So here we can choose an Amazon machine image. MMIs are basically image templates containing software such as operating system, runtime environments, and our applications, which we can use to boot up our applications. And there are some MMIs provided by AWS, and we can also create our own custom MMIs. So right now I'm going to use the Amazon Linux 2 MMI provided by AWS, but later on we'll also use our own MMI. Here we can specify the instance type. I'm going to go with the T2 micro as it's part of the free tier. Oh, no, don't want that. And here we can configure instance details. So for instance, we can specify the VPC in which we want to place it. So this is going to be placed in private subnet A, as it's going to be our backend server EC2. We don't need auto-assign public IP. What we need to specify is IAM role. So IAM roles basically give our instances permissions to access some AWS services. And I pre-created two roles, one for client EC2 instances and second one for server. They basically give our instances permission to use AWS System Manager, which we need to access our instances without SSHing to them directly. So there are some additional settings, but what we care about right now is the user data. User data is a script which is going to be executed at startup of our application. And I have here prepared a small script, which basically it installs Java 11 and fetches from AWS S3 jar file of our application so that we can run it later on. This way, when the instance is already booted up, we'll have those ready. So here we can specify storage for our instance. It comes with some default settings, which are fine for us. I like to add a name tag to all my instances. So for instance, server A EC2. And now we can configure our mini firewalls, so security groups for the instance. I'm going to name the security group server SG, as we'll reuse it for the second server instance. Group for server instances. And by default, we have allowed incoming traffic on port 22 for SSH, but we don't need that because we will not. We will instead use AWS Session Manager to access our instances. So now we can review instance settings and launch it. AWS asks us about a keeper. So AWS uses public-private key cryptography for access to EC2 instances, but we're gonna use AWS Session Manager, so we don't need that. Okay, so now the instance is launching. It's gonna take a while. In the meantime, we can create the second instance, for, this time for our client application in availability zone A. So the same as before, we're choosing the same AMI image, same instance type. This time we're going to place our instance in public subnet A, and we'll use public IP address. IAM rule, this time client EC2 rule. And we'll also use different user data script. So this time, instead of installing Java and fetching a jar file from S3, we're installing Node.js and Git. So we'll use Git to fetch repository later on. Again, we can go with default settings, add a name tag. Oops. We'll create a new security group for client instances, so client SG. Again, we don't need the SSH port open, and we don't need a keeper. Great, so now our instances are still launching, and it's going to take a minute. In real life, we would create, when they are finished launching, we would create the MI images, but I already pre-created them because it takes a while. So here I have them, and we can use them to create instances in a second availability zone, in availability zone B. So let's use this instance. Again, we can choose a different instance type, but we don't need that. So this time we're selecting the private subnet B because we're setting up the EC2 instance for availability zone B, server EC2 role. And this time we don't need to specify the user data script because the software will be already installed because we created the MMI from our instance previously created. So here name is going to be server B EC2. We'll use pre-created security group, the one which we used before. We have a warning, but that we don't have the port 22 open, so we won't be able to SSH, but that's fine. And we'll do exactly the same for the client instance in the availability zone B, but this time we're going to use client AMI. And this one we want to place in public subnet B, allow auto-assign public IP, specify client EC2 role. Again, we don't need the user data, default storage, client B, EC2. And we want to use our previously created client security group. We can proceed without the keeper. Great, so now our instances, all of them, they are launching. In the meantime, we can move to creation of the database. So we're going back to the AWS Management Console. We'll search for RDS service, which is Relation Database Service. And here we can easily create databases which are managed by AWS. So I'm going to just click Create Database. We're going to go through the standard create procedure. We have different engine types. Basically, the cheapest and the fastest is supposed to be Amazon Aurora, and this is the one which is recommended. But for us, we're going to go with MySQL for simple reason that it provides the free tier option, which Amazon Aurora doesn't. So we're going to name our database user manager DB. Here we can set up credentials. So I'm going to set up password admin123. Very secure password. We can set up specified instance size, storage. We have storage auto-scaling. We can't enable multi-LZ right now because we're using free tier, but we will be able to do it after the instance is created. Here we can specify some connectivity options. So for instance, if we want to have our instance publicly accessible or not, and we don't need that because we'll only access it from our server instances, we'll create a new security group for our database instance. So let's name it user manager DB SG and place our instance in availability zone A. So here we can, we're going to use password authentication only and some additional configurations. So initial database name, user manager DB. We don't need backups. And that's it. Now AWS is going to configure our database. That's also going to take a while. So we can go back to our EC2 instances and see if they are finished configuring. So let's first, the way I usually check if the instance was launched is I go to system log, and if there's any system log here, that means that AWS finished. So now we can connect to our instance through Session Manager, and we'll get a nice terminal here. So we're inside our instance, and we can see that here we have user manager service jar. So that's the jar file for our backend service. I'm gonna move this to home sim, then move. Perfect. And we'll see if the Java is installed. It does. So it's almost ready. Now we're gonna check second instance if it's also configured. It should be. It has Java, and it already should have the jar in correct destination because I created the MMI after moving it. Okay. So now let's check on our client instances, client A EC2. If everything went fine, we should have Node installed, and we should have Git. So Node version, Git version. Perfect. And now we'll clone the code for our front-end application. Oops. So now we can run just npm install. It's going to speed up the process later on when we try to deploy application. And let's check up on the client B EC2. This one should already have the project cloned from Git. So if we go to home sim, yeah. So great. So what we did now was we created the EC2 instances, so basically VMs for our applications. We used MMIs to create instances in second availability zone, and then we configured the relation database for our instances. So that's where we are. And the next step is load balancing and application deployment. So we're going to configure target groups, the load balancer, and boot up our applications. So let's go back to AWS Management Console. And as a first thing, let's go check what happened with our database. It should be up and running, hopefully. Yeah, it's available. So now if we click in the DB identifier, we can see all the connectivity and security settings. So we'll need that endpoint to connect to it in a moment. But first, we can click on Modify. Takes a while. OK, so here we can change some settings. And one of the settings we can modify, we can actually enable multi-AZ deployment. And this will result in a creation of a standby instance in another AZ, which would be used if our database failed. Then there would be a quick switch to the standby instance. This one would be promoted to the master. So that's all we want to do right now. There is some performance impact because the database is going to be modified, but we don't care. So one more thing which we need to do right now is our Spring Boot application, when it starts, it tries to connect to AWS Systems Manager and use it as a config server. So it tries to fetch the configuration application properties. And we're using for that parameter store. I have here a couple of properties defined. So it's basically Spring Data Source username and password, admin and admin123, and Spring Data Source URL. We need to modify the URL in order to point to our actual RDS instance. And now when we launch our application, it should fetch those properties and connect to the database. So let's go back to EC2 and now focus on load balancing. So how load balancing works in AWS, load balancer basically have listeners on specific ports and some rules which forward traffic to target groups which contain instances. So in our case, we need two target groups. We need a target group for our server instances and target group for our client instances. So let's start with creating the first one. As we can see, the target and target group can be an instance, IP address, or Lambda function. We'll name this one server TG. And our application is going to be running on port 8080. We want to associate it with our user manager VPC and specify a health check pack. So our application doesn't expose the bare path, so we need to, it's having a user's endpoint. And now we're selecting instances for the target group. So server A and server B, EC2 instance. And that's it. We can create the target group. And now we can configure the second target group, so client AG. The client application will be running on port 5000, also user manager VPC. It can use the bare path or the health checks. So now we need to specify client A and client B instances. OK, now we have two target groups specified, so we can create our load balancer and configure its listeners to use those. So let's create the load balancer. We have three types of load balancers: application load balancer, network load balancer, and classic load balancer. Classic load balancer is basically a legacy solution. Application load balancer is for simple HTTP, HTTPS requests, and network load balancer is for lower level traffic. So let's go with application load balancer in our case. Let's name it user manager LB. We want it to be internet facing, and IP address can be of type IPv4. That's fine for us. So now we need to specify listeners. Our load balancer will be listening on port 8080 and port 5000 for our backend server and for client application. It's inside our user manager VPC, and we want it in both availability zones in our public subnets. Here we can specify some additional settings. That's just a warning that we're using HTTP instead of HTTPS. We should use HTTPS, but for this presentation, I'm going with simplicity. And we'll create a new security group for our load balancer. So user manager LB SG security group for load balancer. So the rules here say that the security group allows incoming traffic on port 8080 and port 5000. That's fine. Now we can configure routing. So we can use existing target group and specify, for instance, server target group on port 8080, health checks. We have our target instances. We can review it and create. So the load balancer is now created. And we can see that by default, it's set up also the second listener to forward traffic to server target group. That's not correct. We want to forward this traffic to client target group. So I'm going to modify this rule. This requires quite a lot of clicks for a simple modification. And just save it. Great, we're almost ready. The last part before we can launch our applications is we need to modify a bit our security groups. So first of all, let's modify our server security group, because we need to allow incoming traffic from our load balancer security group. So on point 8080, and we want to allow incoming traffic from user manager LBSG. That's the power of security group, that we can basically only operate on them and allow traffic from other security groups or ban it. So we need to do the same for client SG, but this time on port 5000. User manager LB security group. This way, the traffic from load balancing will be able to reach our instances. And now the last modification is the user manager DBSG, so the security group for our database. Oh, why can't we? Oh, okay, I selected both of them. Because we need to allow incoming traffic on the port on which MySQL database is going to be listening on from our server security group, so that our server application can actually reach the database, connect to it. Okay, great. So now we can go to back to our instances. Let's start with, this is the client. Okay, let's go one by one. So I'm going to close those and connect once again to server EC2. Move to the home SEM where our jar is. And now we're gonna start up the application. So we just export the Spring Profile active prod environment variable and then run the jar and disown the process so that it doesn't stop when we terminate this session. Now our Spring application is going to start. Yeah, in meantime, we can connect to the second backend instance, server B EC2. And start it. And we can see that it straight away receives some requests. Those are health check requests from the load balancer. So if we actually go back to our target groups, server TG and targets, we can see here that both of them are unhealthy, but in a couple of minutes, it should change to healthy. And we will execute this once again. Let's see if something changed here. Still not, but it takes a moment. So in meantime, we can go to our client applications, client A, EC2, connect it. Go the same to home, sim, to React User Manager. And in this case, I prepared a small script which basically runs npm install, builds the application, and serves it, to which we need to specify as a parameter an URL of the backend server. So that's going to be the URL of our load balancer. So we need this one. And actually, we can check here if our backend server is running. It is, because we're getting empty array. We have no users yet in our user manager system. And we also, without this, and we also want to disown it. And we will want to run the same in the second instance. So this time we're going back to our instances, client B EC2, connect. Home. That's just building our React.js application. We can see that both backend servers are running. We can check on our target groups if they already changed their status. So server TG, yeah, one of them is already healthy, the second one not yet, but that should also change in a moment. And the same should happen. Okay, so the client application in availability zone A is already up and running. The second one is still starting. If we go to target groups and check on the client TG, probably both are still unhealthy. Yeah. Okay, and now if we we can see our application up and running. That's probably from both instances are already fine. So when we refresh the page, this should actually go to the second instance. We can create a user just to see that we are actually operating on the real database. Password 1, 2, 3, 4 main street. Also Poland. Have our user, and if we refresh, we still have it. Even if we kill the instance, so if we use we kill the processes on port 8080, now we don't have any users, but if we rerun the application, the user should be back then, because we will connect back to our relational database. Okay, now we can see that both our server instances are healthy. And in case of client instances are still not recognized as healthy, but they are working. There is usually some delay, which we can also specify from AWS console. Yeah, and we're back. Our user is there. So let's go back. And we did it. So we created an infrastructure with a single VPC. 4 subnets into different availability zones. We deployed our backend application, configuration database, and client application. We configured a load balancer in order to provide high availability. Thank you. So that's everything I had for today. Are there any questions?